Alright, are you guys ready for a new episode of Polishing Turds?
I can't wait!
Oh.
Alright then.
Let's take garbage and make it shine. This whole project is asinine. Waste some time with me, I can guarantee this old junk will soon tone the line. We're polishing turds, mediocrity curve. I can't find the words. This song is absurd. We're polishing turds. We're polishing turds.
Alright, today we're going to talk about the next phase in our little small block Chevrolet build, and that is airflow. We are dealing with these very inexpensive Chinese heads, hence the name of the series here, Polishing Turds, and they are, shall we say, airflow restricted. There's nothing special here, and honestly it's going to be quite a trick getting much out of these things because they have just kind of inherent built-in problems that we're going to have to try to work around. So an engine is basically an air pump. The more air you can pump, the more fuel you can burn, therefore the more power you make. This thing's naturally aspirated, which means that we're requiring on the air pressure inherent in the atmosphere to fill the cylinders. No turbochargers, no blowers, no nitrous oxide, etc. That's our restriction or limitation here. So when you're in this situation, the cylinder head's airflow is king. It's one of the most important parts. It's one of the places where we're going to find our biggest gains, and it's also some of the most labor-intensive parts we're in. Hand grinding cylinder heads is just a labor-intensive grind. There's no other way to put it. It can be very rewarding, and when I started out many years ago, that's kind of what I started out doing, because I realized that heads are where power's at, so I worked a lot on that, and that's kind of where I started honing my craft, and I like doing it. I don't do as much of it nowadays because of the advent of CNC stuff, but I still like doing it when I get a chance. But anyhow, there's gonna be no CNC machines involved in this, and right there is a flow bench. We're not going to use it. We're going to do this completely all natural because this is Polishing Turds. But anyhow, we got to get some airflow out of these things. Now, as far as the airflow is concerned, there are three kind of main areas we're going to be working in. The intake port, which is the most obvious. This is where we're sucking in our atmospheric pressure is pushing in our air. The exhaust port, where we're blowing it out. Pressure in the cylinder is relieved here when the exhaust valve opens, and the better this flows, the more quickly we can blow down the cylinder. Pretty self-explanatory there. And the third part is the chamber itself, and this has to do with more than just flow, but the chamber itself does affect flow, and how that the chamber is designed will change airflow, and there's other power specific things that happen in the chamber that we're going to try to pay attention to. But on a set of heads like this, especially being a small block Chevrolet, there is a specific thing that a lot of times is really what determines how much power a motor can make in the large sense, in my experience. And engineer types, I believe, refer to this as the minimum cross-sectional area or something similar to that. It's been a long time. But what that is the area of the port of any cylinder head that has where its smallest cross-section is at, right? Now on cylinder heads like this, where the camshaft is in the motor where we have a rocker arm and a push rod, or your conventional, like an LS or small block Chevrolet, small block Ford, whatever. This place in the intake port is usually where the push rod is at. All right, so that's kind of an inherent limitation. If you have an overhead cam deal, you don't have push rods. So it's much easier to just make the port bigger. Now, in the case of this thing, and some of your cylinder head guys may squeal a little bit when I say this, but CNC porting, or porting in general, you're refining the shape and making it super efficient and this, that, and the other. Well, the problem that you have in a motor like this is a 383. When the the cross-sectional area is too small, you force the air to do things it doesn't like to do, and the air has to fill the cylinder efficiently with such a small area. It has to travel super fast, and break the sound barrier and do things that nothing likes to break the sound barrier without some kind of assistance, like jet engines or whatever. Well, we don't have any of that, so the way that what happens is the thing will stop at a certain point, and there's math that you can do to determine, all right, if our cross-sectional area is X amount and our motor is this amount, this thing is going to pretty much stop at X amount of RPM. And I've done the math on this one. This one is a inch 9. Our area in the push rod here is inch 950 by 1. That's very small, inch 950 cross-sectional area. What the math says that this motor's going to be, no matter how you cam it, it's not going to keep increasing in power past 5600, right? And this math works out, in my experience, works out really well, and it's a very effective tool in kind of understanding and targeting where you need to be with the port shape, and it kind of trumps everything. It doesn't matter what the head flows. If you have a cross-section problem, the motor's going to stop at X amount of RPM, kind of almost period. It's kind of a hard wall of science there that just happens, and if you're going to get past that, you just need to make things bigger. That sounds like a dumb thing to say and counterintuitive to maybe a lot of the cylinder head talk you've heard over the years, but in this application, we just got to make this thing bigger to a certain extent. Our area right here is really small. We can't make it big because of the way this thing is. It's just, there's only so much we got to work with. But the first thing we're gonna do is try to see what we can get out of this area to improve things, so I kind of know where this motor's gonna be capable of going. If I can only get this number up to say 2.2 or something, we're not gonna do a whole lot better than we did before, because the motor's just not gonna turn that much. It's not gonna turn that much, it's not gonna make a lot of power. But anyhow, so the first step here, I'm curious to see where I can get the cross-sectional area by opening things up in here and playing with this a little bit. So let's do that and see what happens. Okay, I've got this intake port more or less done, or as far as I'm going to take it right now. But anyhow, you can see I've raised the roof. I'm trying to did it like this so you can see a little bit of the difference. And that's kind of confusing because it's all shined up in here, and it kind of makes it a little misleading. But you can see it is a little taller. The width right here is more or less the same, no matter how it looks. But in here at the push rod pinch, it is wider. Now to demonstrate that, to measure that, I use snap gauges. And now we're about 1/1 wide there, which is, it was, what was it? 1. So we've picked up just over 100 thousandths in the push rod width wise. Now you see over here, this won't go. It lacks a little bit from going. Now height wise, same deal. I'm at 2085 now or so, height wise at the push rod pinch, and that's not going over here. So those are the basic differences. Everything else we've cleaned up, shaped up a little bit, but as far as what this thing's going to see on the dyno power wise, that's where we're going to gain some, because that'll allow us to turn the motor more. And you know, you need RPM to fill those cylinders more times per minute, you know, efficiently with big gulps of air. To do that, you have to have a window that is a certain size. That's just kind of how it is. Now here we've reshaped this, cleaned things up, opened things up, moved things back a little bit, to take account for the bigger valve. The shape of this thing out of the box really wasn't terrible. I guess they copied those dumb Americans pretty good. Dumb round eye. So we just kind of refined that a little bit. Like I said, the main changes here, right here in the push rod. Anyhow, now let's move on to the exhaust. We'll clean that up. Alright then, got our exhaust port tuned up a little here. Now if you look, I know it's kind of confusing with the shiny versus dull carboned up, but it's really not increased in size much at all. I mean, maybe just a little bit side to side, hardly at all, and just a little bit up. And the reason being is it's big enough for what we're trying to do. It's not a blower motor, and we're limited on the intake side, so we're not going to be able to turn it 8,000. So it doesn't need a massive port. A massive port will just hurt things. It'll just kill. It won't help at all. So basically what we've done in here is just do things to improve the efficiency. You know, the flow should be up for a relatively small increase in size. Let's get a look at the other view here. We just kind of shape things up to flow a little better. We increase the throat diameter some. We can do that with this valve job with a 55-degree seat. I just did that by hand. Open that up right in here a little bit, and just inside the seat, just to get this diameter here. Usually, a lot of times I'll set that as a percentage of valve diameter. In this case, I just kind of winged it and just blended it into the valve job where I felt it would do good. And this should be a lot better than what it was. If I were flowing this, I would say it probably picked up 30 CFM or something like that from beginning to start, maybe more than that, maybe 40. Okay, so now we're going to move on to The chambers, get them dressed up a little bit. Anytime you put bigger valves in something, especially stuff like this, a wedge head, you can run into shrouding issues where the bigger the valve is, the more it gets close to the chamber right here. Yeah, it's hard to hold this camera. But we get tight right here sometimes, so sometimes we'll open that up a little bit. We'll look over here on the exhaust side too. And you know, really this one's not that bad at all. So I'm just going to clean things up. The biggest thing is we're going to blend this into the valve job. Our valve job here is fairly invasive, so there's a pretty big step around all this. We're going to clean that up, shape that up a little bit. The general shape of this chamber is fine for what it is, you know. Going to blend this back onto this side. It definitely needs some work here. But we're not going to go crazy. Some stuff you do, like old Ford high ports, they're a great head. They come with a pretty tight chamber. Well, by the time you put like a 2100 in there or whatever, and trying to get 350 out of them, you've got to open up a bunch to get room to do it, and it kills compression. You end up with a big 70 plus cc chamber to start with, but you have to do it in some cases. But in this deal, we're not going to need to go crazy there. So we're going to keep it simple and slick this up, and then we'll be done with this one port, and we'll copy it to all these other ones. Alright, so we've got a port and chamber or two done here. These are kind of where we're going to leave things for now. We're going to obviously transfer this to the rest of the ports and then surface this thing, skim a little bit off the deck and put it together, and we'll be ready to go in that department. There's definitely possible places for improvement in the future, so maybe there will be a polishing turds part 2, the freshening, when because Dan's probably gonna just go to just whipping ass and taking names, winning races right and left. So we'll have tons of money here shortly that he could maybe next year spend on freshening this thing, and we'll take it to we'll polish this turd to just an unbelievable luster next year. But anyhow, that's where we're gonna stop here. So numbers wise, our pinch area here was at 1.95, and now we're up to about 2.3, and the quick math says that our other motor would stop at about 56 or so, and now we can go to 65 or so, right? So that's a big improvement. Obviously, I'd like to be able to even go farther than that, but that involves getting risky on getting through here, and I don't want to get into welding stuff up and fixing stuff and going into spring pockets and just a bunch of crap. It's a pretty good start. We'll probably make a lot more power than you did before. And anyhow, let's see where this goes. Anyhow, we'll finish up the rest of the head. And then what's next? I guess at some point we got to do some assembly. So maybe that'll be the next episode. I don't know. But anyhow, that's enough polishing turds for one day. I've had enough of this mess. So anyhow, later.